Hello, welcome to my channel, Math Made Easy with Laurel. My name is Laurel, and in this video we're going to start our journey with factoring. So factoring is a necessary skill because you'll need it when you're solving certain types of equations. You'll need it when you're simplifying algebraic expressions, and you'll also need it when you're working with algebraic fractions. So it's not something we can avoid. we need to have this skill. And I'm going to help you with different strategies and approaches depending on what kind of expression you're dealing with. But the number one rule when you're factoring is to look to see if you have a common monomial factor for every term. And if you do, factor it out, because once you do that, then what you're left with will be easier to further factor. So to take a look at this example to show you what I mean, you look at what divides into both this term and this term. And we look at the number part first. So what number divides into both 2 and 6? And that would be a 2. Then I look at the powers of x, and what's the highest power of x that will divide evenly into x squared and x, and that would be just an x. So I take that out or factor that out, and when I factor it out, I basically divide this into each term to get what's left. So 2x squared divided by 2x is x. 6x divided by 2x is 3. I can check whether I factored correctly by simply multiplying this, and I should get back to that. So 2x times x is 2x squared plus 2x times 3 is 6x. So it's the reverse of multiplying your polynomials. You're dividing it up into factors. When you're factoring a common monomial factor out, it has to be of every single term. So if it isn't in every single term, such as this example, don't partially factor. I don't like to see partially factoring because it's going to cause you difficulties and possibly make you think you can do things that you can't do. So when we get into grouping, factoring by grouping, I'm going to do it for a part of it, but not as a final result. So that's what I mean by a common monomial factor. You do that first before continuing on with factoring. Let's look at a couple more examples. In example 2, we have 3 terms. We start with the number 30, the numerical coefficients, 35, 15, and 5. And there's a factor of 5 in each of those. 5 is the largest number that divides into each of those evenly. Then I look at my powers of a, and what's the largest power of a that will divide into all 3 terms evenly, and that would be a squared. It's going to be your lowest exponent, so I can factor an a squared out. I look at my powers of b, b to the 4th, b to the 5th, b squared. So the highest power of b that goes into each of those evenly is the lowest exponent, which is b squared. And then I look at my powers of c. I have c squared, c cubed. So the largest power of c is the lowest power, which is c to the power of 1, that I can factor out of each. Now, to see what I have left when I factor that out, I divide this into each term. So 35 a cubed b to the 4th c squared divided by this, 35 divided by 5 is 7. A cubed divided by a squared would be a to the 3 minus 2, which is 1. B to the 4th divided by b squared is b to the 4 minus 2. And c squared divided by c is c to the 1. I do that for each term. So my next term, 15 divided by 5 is 3. A squared divided by a squared is just simply a 1, a to the 0 or 1, which I don't have to indicate. B to the 5th divided by b squared would be b to the 5 minus 2, which is b to the 3. C divided by c, again, is c to the 0 or a 1, which I don't have to write. Last term, 5 divides into 5 one time. I don't need to put the 1 as a coefficient. A to the 4th divided by a squared will give me a to the 4 minus 2. B squared divided by b squared is b to the 0 or a 1, which I don't have to put. C cubed divided by c will be c to the 3 minus 1, which is 2. So that would be that expression factored. Now, when you're doing a common monomial factor, sometimes you might see things like this, where it's not just factors, we actually have an expression. So what I want you to think of this is just like I thought of, just like an x. Think of that like an x and that like an x. So in other words, if I had 3tx minus 5x, that's a common factor to both of these terms. So I could factor out the x, and then I'm going to be left with 3t minus 5. That's going to be true if you have an expression like n plus 1. Treat it like you treated the x in this example. So because 3t is multiplied to this and 5 is multiplied to this, n plus 1 is a common factor to both terms. So therefore, I'm going to factor it out of both terms. So I'm going to have n plus 1. And when I factor it out of this term, I'm left with 3t. When I factor it out of this term, I'm left with minus 5. And again, we could check it by multiplying this to each of these terms to see that I get back to what I started with. Same thing here, I can check whether the factoring is correct very easily because I can multiply this through to each term and see if I get back to what I started with. So that's your first step in doing any kind of factoring. See if there's a common monomial factor to every single term, and if so, factor it out. Once you've done that, then you can look at the next techniques or strategies when you're doing factoring. So in these cases, I'm completely factored. There's nothing else I can do with these, but we're now going to look at other types of expressions and other types of approaches for factoring. So practice this first, and when you're ready, let's move on to the next video on factoring. Take care and see you then.